The problem is currently the industry need to conduct the process of inspection manually. It has a fixed platform that used to put the workpiece one by one manually. Then the grabber of the camera is adjusted by the manpower itself. This took a lot of time to complete all the process and it is not economical. This condition causes the product produced becomes low, since the workpiece of welding groove may fall down and becomes damaged.
Designing and implementing visual sensor platform is the title of our solution. The platform would help the industry to use an automatic process of inspection, decrease the usage of manpower, reduce the time consumed, and increase the productivity. Designing the platform, we have designed three designs have been discussed and one have been chosen. Design number 1 uses 2 DVD drives. Design number 2 uses 1 infrared sensor and separate camera laser platform. Design number 3 uses 3 infrared sensor and connected laser camera platform. Design number 3 have been chosen and drawn using Infinita software. This video shows that we can extend the platform that will help to have an internal view, and hence damages or errors can be easily detected. Moreover, we can have a view of every part of the platform separately. Therefore, the platform is easy to be maintained, and replacing elements after use such as screws, belt, or laser camera platform would be smooth. Lastly, the colors used, such as yellow color, is the standard color that indicate high temperature. Standards we have referred to are International Electrotechnical Commission IEC 61850-3 2013 and Electric Cable and Wire MS 2112-1 2009.
From engineering perspective, the materials used for the platform are designed to the highest standards. They are able to transport all type of bulk material for visual inspection. The conveyor with the less friction was used so the belt runs smoother and faster. The conveyor belt was made of 3 layers with rubber as the skims. It reduced friction for the belt to move and sustainable. The conveyor belt is set to high speed so it can improve the productivity. Therefore, more workpieces are able to be inspected within a short time. The level of the camera and laser of the aluminum grabber can be adjusted accordingly. Therefore, the grabber doesn't have any constant height. The camera and IR sensor will detect any object that passes through, and it will show the exact measurement of the workpieces at height. For power supply, an approximate 50-volt DC power supply was used to move the motor and IR sensor. Maximum 25 volt was needed by the motor to rotate the conveyor and 12 volt for the IR sensor to send the signal.
I will talk about control model for our project. We choose Arduino Uno as our project controller because this is open source and have larger library collection. It has simplified and user-friendly programming language and no additional programmer or burner hardware required for programming board. In our project, Arduino Uno will communicate with 1 stepping motor and 3 IR sensors. When first IR sensor detect object, stepping motor will start running. But if object detected by IR2, stepper motor will stop running 1 second and continue running. Last, when the object detected by IR3, stepping motor will fully stop.
Infrared sensor is an electronic instrument that is used to sense certain characteristics of its surroundings. It does this by either emitting or detecting IR radiation. IR sensor also capable of measuring the heat being emitted by an object and detecting motion. When a moving object that generates IR radiation enters the sensing range of the detector, the difference in IR levels between 2 pyroelectric elements is measured. The sensor then sends electronic signal to an embedded computer. Advantage of IR sensor is it can be used in reduced oxygen or even in an environment. It is also used to reduce the power consumption of sensor.
For the IoT part, we are using ThinkSpeak to display the number of objects that pass through the first sensor.
In the
object pass through the first sensor, the data will be sent to TeamSpeak using ESP8266 Wi-Fi module. A graph will form indicating the number of objects that pass through the first sensor.